By solution of two or more linear equations, we mean a common point through which every participating line passes. Just like intersection of roads. Although we have numerous methods to find coordinates of such a common point, but here we will be using a method called solution of linear systems by substitution. Let's get started with this question. Here we have at least one variable with the coefficient 1. So if we name this first equation as equation number 1 and name the second equation as equation number 2, we should be using the equation in which the variable with coefficient 1 is available. But here y, you can see that the variable y has coefficient 1 in equation 1 as well as it has minus 1 in equation 2. So we can use either one of them. Let's use from equation 1. From equation 1, we are going to get value for y. Y is equal to, this is done by isolating y on one side and transferring everything else on the other side of the equation. So here we got y is equal to 1 minus 2x. We transfer 2x on the right hand side of equation 1 so that y is isolated on the left side. Now this is value of y and we will substitute this value in equation number 2. Substituting this value of y, in equation 2 now. Once we substitute, this will become 3x minus, instead of y we just use brackets and we put 1 minus 2x is equal to 4. So instead of y we are writing its value, which is 1 minus 2x, which we have obtained from equation 1. Now simplifying this expression here, 3x, and now when minus multiplies inside, this will become minus 1, and then minus time minus will become plus 2x equal to 4, and like terms could be added, like 3x and 2x when added they give us 5x, and minus 1 will transfer on the other side because we want to collect constants on one side and variables on the other side. So this will become 1 plus 4. Here we get 5x equal to 5, and according to the laws, now we want to isolate x, so 5 is multiplying on this side. If we divide 5 on both sides, what we get here is x equal to 1. So this is the abscissa of the solution. Like for the solution we need both x and y. We got value of x here, and now we will substitute this value of x in equation 1. So substituting value of x for this value of x, y is equal to, what was the value of y we have already concluded from equation 1? That was 1 minus 2x. 1 minus 2x. So now when we substitute x equal to 1, so what will this become? Y equal to 1 minus 2. Instead of x, now we are going to put 1, and this will give us 1 minus 2. So what will be value of y? That will be equal to 1 minus 2, that is equal to minus 1. So we got both the values for x and y, and now the final step, we will verify. So for verification, we will take both the equations, and on both sides of this equation we will substitute. What was the first equation? The first equation was 2x plus y equal to 1. So this would be 2x plus y equal to 1, and the second equation is 3x minus y is equal to 4. 3x minus y equal to 4. So let's substitute x equal to, what was the x equal to 1 and y is equal to minus 1. If this pair xy is on this line, then it should give us the true sentence, like 2 times instead of x, that is 1, plus instead of y we can say minus 1 equal to 1. So this should be 2 minus 1 equal to 1, and 1 is equal to 1. So equation 1 is satisfied for this pair of x and y, means that this point 1 minus 1 lies on line 1. And let's see the second line here. The pair is 1 minus 1, means the x is 1 and y is minus 1. 3 times 1 minus, instead of y again we have minus 1 equal to 4. So this is 3, negative times negative will become plus 1 equal to 4. 4 is equal to 4. This is a true sentence. Therefore, we can say, therefore, the point 1 minus 1 lies on both lines. On both lines, and we can say that the solution of the linear system is 1 minus 1. Hence, solution set. Hence, solution set is equal to 1 minus 1 for both of these lines. Let's do another question. And the second question is in which the x and y, their coefficients are not 1. None of the variable has coefficient 1. So what are we going to do about those questions? For that is, we will use the procedure 2, and this is 2x plus 3y equal to minus 5, and the second equation is x over 2 minus y over 3 minus y over 3 equal to 2. If that is the case, let's call this as equation number 1 and call this as equation number 2. We can find the value for x or y either from equation 1 and 2 and substitute it in the other equation, just like we did in question number 1. But if we would like to go easier way, what we should do is, what is the leading coefficient? LC for leading coefficient for equation 1, that is 2, including the sign, and LC for number 2 equation is 1 over 2, the coefficient of x in equation 1 and in equation 2. Remember that these terms must be aligned before finding the LC, means x below x and y below y. And once we have LC, leading coefficient for equation 1 is 2, this coefficient, and for the equation 2, this 1 over 2 is the leading coefficient. So here, now we are going to multiply equation 1 with the leading coefficient of equation 2, and we'll multiply equation 2 with the leading coefficient of equation 1. Means that 2x plus 3y is equal to minus 5, and this whole equation will be multiplied with 1 over 2, and the second equation, which is x over 2 minus y over 3 equal to 2, this whole equation will be multiplied with leading coefficient of 1, equation 1, which is 2 here. So what we get here, this is still equation 1 and this is still equation 2 because nothing has changed. Multiplying any equation both on left and right side by same number, that doesn't change the value of equation. So this will become, if we multiply 1 over 2 times 2x plus 1 over 2 times 3y equal to 1 over 2 times minus 5. So that is still equation 1, and 2 times 1 over 2x minus 2 times y over 3 equal to 2 times 2. So this is still equation number 2. We are maintaining the order here, and this x2 is gone with 2, this 2 is gone with this 2. What we have here is x plus 3y over 2 equal to minus 5 over 2. And for second equation, we have x minus 2y over 3 equal to 4. This is still equation number 1 and this is equation number 2. So we have done this procedure, and as a result of this procedure, what we have seen both in equation 1 and equation 2, x in both equations have the same coefficient. So now we will do the same procedure which we did in equation 1. From equation 1, we will find out the value for x. We will isolate x. This will become minus 5 over 2 minus 3y over 2. So this is from equation 1. Either you can use equation 1 or equation 2, that doesn't matter. So substituting this value of x in equation number 2. Substituting this value of x in equation 2, what we have here is, instead of this x, we will write this value, which is minus 5 over 2 minus 3y over 2 minus 2y over 3 equal to 4. So in equation number 2, this is, we have replaced x by its value from equation 1. So once we have done, now what we will be doing, we want to keep variables on one side and constants on the other side. So if we keep the terms involving variables on this side, this will become minus 3y over 2 minus 2y over 3 is equal to 4, and then plus 5 over 2. That will be shifted on the other side. So here, if we take an LCM, the LCM would be 6, and this would give us 6 and minus 9y minus 4y equal to, here the LCM would be 2 and this would be 8 plus 5. This is simplification of fractions. A very handy skill. Minus 9y and minus 4y will become minus 13y over 6 equal to 13 over 2. So here, now if we want to isolate y, what we should do here is we can minus 13y over 6, we can multiply it with minus 6 over 13 on both sides. 13 over 2 times minus 6 over 13, so that y is, this is the multiplicative inverse we are multiplying so that we can get y isolated. So here this 13 is gone with this, 6 is gone with this, and this 13 is gone with this, and what we have here is minus 3 as value of y. Now once we have got value for y here, we can go back and substitute this value of y in equation 1 to get the value for x. So substituting value of y, substituting value of y in equation 1, what we receive is 2x, that is equation 1, 2x plus 3. Instead of writing y, we can say minus 3 equal to minus 5. So now there is only one variable x, and here we will have 2x, and 3 times minus 3 will become minus 9 equal to minus 5, and 2x will be on one side and minus 9 on the other side will become plus 9 minus 5, and this will become 2x equal to 4, and if we divide both sides by 2, this will give us x equal to 2. So now the solution we have for this system, solution for the system is, for system of linear equations, is 2 and what was the y? Y was equal to minus 3. So 2 and minus 3. We haven't verified this solution yet. So for verification, we are going to write both equations, one on left side, one on right side. So let's write down 2x plus 3 y, 2x plus 3 y equal to minus 5. And the other equation is x over 2 minus y over 3 equal to 2. So let's see if this point 2 minus 3 will satisfy both of them. At x equal to 2 and y is equal to minus 3, 2 times x, what is value for x, that is 2, plus 3 times y, what is value for y is minus 3, must be equal to minus 5. Let's see. This is 4, this is minus 9 equal to minus 5. Minus 5 is equal to minus 5. This sentence is true sentence. And let's take a look on the what is happening with the second equation. Instead of x, we're going to substitute. So for x equal to 2 and y equal to minus 3, what we have is 2 over 2 minus, instead of y we have minus 3 over 3 equal to 2. You can see that there is a negative sign in front of another negative sign. So 2 will cancel with 2, 1, and then plus 1 is equal to 2. 2 is equal to, that is also true. So we have proved that this is, thus the solution 2 minus 3 is solution of linear system, is solution of given system. So this is how we can use substitution method for finding solution of system of linear equation given system. So in next video we will discuss another method